As part of writing or modifying a laboratory procedure, you might be asked to calculate a target volume with titration data. So in these examples, we're going to continue with this concept of having an acid as our analyte and a base as our titrant. And perhaps you're asked to calculate how much base you would need to see if a 50 milliliter burette is the right container, or perhaps you're trying to figure out how much of your acid sample to put in the Erlenmeyer flask so that you can use the amount of liquid in the burette. So how many milliliters of 0.1 molar sodium hydroxide titrant? So that tells us right away sodium hydroxide is our titrant. The concentration is 0.10 molar. And we want to know how many milliliters of that titrant are required to titrate. Down here we have KHP, so this is a standardization titration where we have a known amount of this. We think our titrant's about 0.1 molar. We have 0.741 grams of 92.58% pure KHP. So again, look for what you're trying to calculate. Sodium hydroxide, you want to start with the other chemical. So we're going to start with grams of KHP. And we're trying to go to milliliters of sodium hydroxide. Two different chemicals, so somewhere in the middle we're going to have a mole to mole conversion. Moles of KHP going to moles of what we're trying to get to, sodium hydroxide. And then we need to sort of connect the pieces. And on the right we have a typical solution stoichiometry setup. We'll go through liters using the molarity, and then SI prefixes to go from liters to milliliters. And on this other side, we need to be careful. I put grams of KHP. I shouldn't have. This is grams of standard, which we need to use the percent purity to go to grams of KHP. Then we can use a molecular weight to go to moles of KHP. Once you have your dimensional analysis set up, then you can start plugging it in. But again, what we have here is the chemical we're trying to calculate something about on the right, and on the left, the other chemical, the material we started with. Okay, so I'm starting with grams of standard, 0.741 grams. 100 grams of standard contains 92.58 grams of KHP, the potassium hydrogen phthalate. Then the molecular weight is 204.22 grams of KHP per 1 mole of KHP. So the grams are on the bottom, so they cancel. And now I'm to the mole to mole conversion. And so I have moles of KHP on the bottom and moles of sodium hydroxide on top. And from the balanced chemical equation, it's a 1-to-1 stoichiometry. Okay, and now this is the step where I'm going to use molarity to change from moles of sodium hydroxide to liters of the sodium hydroxide solution. And that's the 0.10 moles per 1 liter. So that's now liters of sodium hydroxide solution, liters of the titrant. And to get to milliliters, just the SI prefix. 1 liter is 1,000 milliliters. And this comes out to be 33.5921 milliliters. And looking back through, I should have 2 significant figures from that concentration of the titrant right there. So 34 milliliters. So if my titrant is really 0.1 molar, I should expect to use about 34 milliliters. And 34 milliliters is a good volume for a 50 mil burette. You really want to be in the 30 to 45 type of range, in my opinion. That gives you relatively low percent error or measurement error, without getting near the maximum capacity of 50 milliliters, where you might need to stop and redo the titration if you went over that amount. So 34 is a good amount. We've checked it, and this would be a good start on the procedure. Conversely, we might be know more about the titrant amount we want to use and be calculating how much unknown we should add to the experiment. So in this example, we have how many milliliters of sulfuric acid. That's still going to be down here. But I could use different pipettes to put different specific amounts in there. We expect the sulfuric acid to be 0.160 molar. And of the titrant, it's going to be sodium hydroxide titrant. And we know we want to use about 40 milliliters. So that's a target amount. That's how much makes sense, I guess, in a 50 ml burette as a starting point. And we want to see what a reasonable amount of sample would be. We also know the concentration of the titrant is going to be about 0.1 molar. So in this case, we're trying to calculate something, milliliters of the sulfuric acid solution. And we're going to start with the other chemical, in this case the milliliters of the sodium hydroxide solution, the titrant. In the middle, a mole-to-mole conversion. And we're going to go through liters on both sides. These will be SI prefixes here. This will be molarity, this will be molarity, and then a balanced chemical equation, the coefficients for the mole-to-mole conversion. The most common mistake in this problem would be mixing up which concentration and which volume go where. So we want to be a little careful. The volume of sodium hydroxide is that volume in the burette of the 40 milliliters. The SI conversion, 1,000 milliliters to 1 liter. That got us to liters. Now we're going to use the molarity to go to moles. So exactly 1 liter, and the concentration of the sodium hydroxide this time is the 0.10 moles. And let's go ahead and write that in. That's moles of sodium hydroxide. We then need to use the balanced chemical equation to change moles of sodium hydroxide to moles of sulfuric acid. And as we do this, we're going to go to the balanced chemical equation and pull out the coefficients. As 1 mole of sulfuric acid will require 2 moles, that 2 right there, of sodium hydroxide. Now in moles of sulfuric acid, so there, need to use the molarity to go to liters. This time it's the molarity of the sulfuric acid, so this number down here, and 0.160 moles of sulfuric acid is 1 liter of the sulfuric acid solution. And we wanted milliliters, so we need to use the SI prefix to change back to milliliters. I'm going to go ahead and cancel these 2 1,000s before I punch it in my calculator. You can type them in, it won't make a difference. But I come out and I get 12.5 milliliters. So about 13 milliliters. Now, unfortunately, I don't have a 13 milliliter pipette. I have a 10 milliliter pipette, I have a 25, I have a 5, I could do 15, I could do 10, but I might choose to say, well, you know what, I want to use 10 milliliters, and then I can do a similar calculation in the other direction and figure out that that would require me to start with about 32 milliliters of titrant. Same calculation, just backwards. And I might look at it and say, you know, I can live with 32. I'd like it a little higher, but then I can use my 10 milliliters. So again, this would be a calculation you typically do as part of planning or modifying a procedure to work for your samples. And it's very similar calculation to what we did with the molarity, but instead of stopping at moles and then putting that in a new calculation, you continue to milliliters.